Yeah, 3 through 8 are all relatively straightforward because x is in the denominator of everything. And so as soon as you divide a number by x and let x go to infinity, that number is going to 0. So all of these, 1 over x goes to 0, 5 over x squared goes to 0, and so forth and so on. So 3 through 8 are all fairly simple. 9, a little different. The limit of sine of 2x over x as x goes to infinity, not 0. If x was going to go to 0, I could solve it very simply by multiplying top and bottom by 2. But x going to infinity, what is the sine of 2x? Well, let's just take this problem right here. What's the limit of the sine of x as x goes to infinity?
That would be, wait, say one more time, actually, sine of x as x goes into infinity.
Yeah, the bottom problem on my page.
Okay.
What is that?
Just 0, because it would be multiplying everything by 0.
Remember, this is what the sine function looks like. So as I go further on the right, out to infinity, the limit doesn't do it doesn't go to a number. It's undefined. I suppose that's the same as does not exist. But notice the sign is just merely bouncing back and forth between 1 and minus 1 as you go to the right on the x-axis. You with me?
Okay. Yes.
So now, taking the sine of 2x doesn't really matter. What I've got is the top going between 1 and minus 1. Let me write it like this, even though I would never write it like that. But the bottom's going to infinity. So if the top's going to a number, even though it isn't, it's undefined, but we know it is, it's got to be a number between 1 and minus 1. And if I'm dividing that by infinity, what does that whole thing go to?
0.
Do you have answers on these?
I can pull them up in the back of the book.
Yeah, look and make sure we're doing this right. Number 9, just make sure it says 0.
Okay.
Not undefined. I'm 99% sure that it's 0, but I'm not 100% sure. So before we go on and I give you a bunch of false information, I'd like to verify that this says 0.
Okay, give me 1 second.
Because these are a little tricky when you have oscillating functions. The limit doesn't really exist. Although, when you divide by infinity, it changes things a little bit. We don't know.
And about number 8. Okay.
Number 9 is what we want.
Or number 9, okay. Almost there.
Okay.
This is chapter 2. And it says 0.
Yeah. Well, that's what I came up with. So, okay. So we're doing it correct. Even though the limit of the numerator does not exist, the fact that I'm dividing it by something that goes to infinity, I know that's 0 as long as I can know that the numerator is going to be somewhere between 1 and minus 1, always. Never gets away from 1 to minus 1. It could be 0, but 0 divided by infinity is still 0. So as long as that numerator is in that range from minus 1 to 1, you divide that by infinity, you get 0.
Okay.
Okay. Number 10 don't think it's going to be much different. Cosine of infinity, what's that go to?
So it starts off upwards at the top at 1, I believe. It doesn't start off at 0.
Well, you're right, but where it starts doesn't matter. It's what it does.
Infinity.
It does the same exact thing as sine. When I go to negative infinity, that thing does not exist. But it's between 1 and minus 1, always. So the numerator, even though the limit of cosine of negative infinity doesn't exist, I know it's a number between 1 and minus 1, and if I'm going to divide that by minus infinity, what do I get?
0.
Yep. That's a case where it doesn't matter whether you're dividing by minus infinity or plus infinity, because plus 0 is the same as minus 0.
A lot of these are 0.
What's that?
But a lot of these are seeming to be 0.
Yeah, well, these are particularly different. It's unusual when you have the numerator not defined or does not exist and the denominator does, being able to put them together. You can't always do it. In other words, if I said, what is this limit? Well, no, if I said this, what's that as x goes to infinity?
So solving algebraically, infinity over sine.
Just think about it. What's the numerator do?
It'll be infinity.
What's the denominator do? It bounces between minus 1 and 1.
So it'll be 0.
No. Infinity divided by any number is infinity. In other words,
Okay.
infinity divided by 3 is infinity. Infinity divided by 1,000,000 is infinity. As long as you've got infinity in the top and don't have infinity in the bottom, then this thing, the top is going to blow up faster than the bottom and you're going to go to infinity. Okay.
Okay.
Let's look at 11.
So limit equals t or L. Yeah, t is infinity.
And let's see, t is going to negative infinity.
Yes.
So the top is going to positive infinity, right?
Yes.
In other words, if I take 2 minus, if I just do direct substitution, let's see what we get. 2 minus negative infinity plus sine of negative infinity all over negative infinity plus cosine of negative infinity. Well, we know these bounce between 1 and minus 1, but this negative infinity actually turns positive. So the real problem I end up with here becomes positive infinity divided by negative infinity.
That's weird.
It is. It's indeterminate. In other words, infinity divided by infinity is indeterminate. So whether it's positive and negative or not doesn't matter. That's still indeterminate. Do you have your book still open to the answer?
I can pull it up. Yes, I
It
do.
either does not exist or it's undefined. I'm not sure what they're going to say. I'm thinking they're going to say does not exist on number 11.
It says -1.
Does it?
Yes.
Interesting. How are we going to get -1 here? It's tempting. It was tempting for me to say positive infinity divided by negative infinity is -1, but that's not really true. Infinity, well, maybe it is true now that I think about it. Before we talk about 11, let's talk about 13.
Okay.
And you'll see why I want to do that. What's 13 go to as x goes to infinity?
That'd be 3/7.
No, it's 2/5. In other
Really?
words,
Even though,
the only term that matters is the highest degree of x. You can forget about the 3 and the 7. Because all you care about is that ratio. Because it's x over x, both to the 1 power, then the limit as you go to infinity is 2/5. And the limit as you go to minus infinity is 2/5 also. And
okay.
that kind of gets back to the problem number 11, where I basically had minus t over t, which is the ratio of those coefficients, -1. So that's why it went to -1 on number 11, is because the highest degree variable was t in the numerator and t in the denominator, and I don't really care about anything else. As the thing goes to negative infinity, then it's the ratio of those coefficients, -1. How about 12? What's 12 go to? Under the same exact logic.
Okay, so infinity plus.
No, don't even think of it like that. Think of it as focus on the polynomial only. The highest degree is r to the 1. And in the denominator, the highest degree is 2r to the 1. So what's the ratio of those coefficients?
1/2, pretty much.
Yeah. I can ignore the 7. I can ignore the signs because, can I? Yeah. In other words, here, let's go down and look at number 21. Well, we don't need to go all the way to 21. 14 is a good one. What happens to 14 as we go to infinity?
2.
Yes. The only thing you care about are the highest degree. You don't care about that x squared or x or 7 in the bottom. You can just cross those out and deal with 2x cubed divided by x cubed. And that goes to 2. And doesn't matter whether x is going to negative infinity or positive infinity. It's still going to go to 2. See why?
Yes.
Because 2 times negative infinity cubed is still negative infinity. So it's -2 infinity divided by infinity cubed, which is just infinity. So it still goes to minus hold on a second. Yeah, because the minus signs are going to cancel out. So it still goes to 2. You don't have answers for 12, so we can't check that, but I'm pretty sure it's got to be 1/2. 13 we did. 14 we did. 15. What's 15 go to as we go to infinity?
1 over 1.
No, in 15, notice that the highest degree in the denominator is x squared.
Yes.
Highest degree in the numerator is x. Deal only with those and you end up with 1 over x, right?
Yes.
And as x goes to infinity, that goes to 0.
Okay.
Okay? Again, you don't have to pay any attention to the 1 or the 3. The only thing we're going to look at is the polynomial and its degree. And when the bottom is bigger than the top, always goes to 0. It's basically, if I told you what's the horizontal asymptote for 15, you'd have said 0 because the bottom is a higher degree than the top. Well, the horizontal asymptote is the same question as what does it go to as x goes to infinity. That's what the definition of a horizontal asymptote is that's what the function goes to as you go to infinity. And negative infinity is the same thing. It's still going to go to 0. So 15a is 0, 15b is 0. 16.
So it would be 3 over x squared.
No, it's still 0.
Darn it. Okay.
Because the bottom, think of it as the bottom's going to blow up much faster than the top because it's being squared. So whatever number I put in for x, as it gets bigger and bigger, the bottom gets much, much bigger than the top does. Notice that if I plug in 1 for x, it's just 1 over 1. But if I plug in 100 for x, it's 100 over 10,000. If I plug in 1,000,000 for x, it's 1,000,000 over 1,000,000,000,000. So the bottom is blowing up much faster than the top, and as we get to infinity, we're going to have a bottom that's infinity and a top that's not. So, and if it's reversed, if the top is bigger than the bottom, like 21, what's 21 go to?
It would be, so I see the 3x squared, but that would be, yeah, so just be 3 over.
Only if those exponents are the same is it that ratio of coefficients.
Okay.
If the top exponent,
that a little bit more?
yeah, if the top exponent is 7. So the real problem I'm looking at, here, let me write it. The real problem I'm looking at is 3x to the 7th divided by 6x to the 3rd. Well, the 3 and the 6 don't really matter. If I just took x to the 7th and divided it by x to the 3rd, I would get x to the 4th. What does that do as you go to infinity? It goes to infinity.
Okay. Now I see what you're talking about.
So there's only 3 situations. There's the situation where the exponents are the same, then it's the ratio of the coefficients. Second situation is the exponent in the top is bigger than the bottom. That always blows up to infinity. And the third situation is if the bottom is bigger than the top, that always goes to 0. Now, there is one exception that let's talk about in terms of infinity or negative infinity. What if I had x to the 5th over x squared? What's the limit of that as x goes to minus infinity?
So it would be x cubed.
Right?
And that would make it 0.
No, plug in infinity for x there. Minus infinity cubed. What happens when you cube a negative number?
it becomes negative still.
So negative infinity is the answer.
All right, so I just leave it at that.
Huh?
So I just leave it at negative infinity.
Well, it's because this differential is odd. If I subtract those two numbers and get an odd number, then when I go to positive infinity, that goes to positive infinity. But when I go to negative infinity, it goes to negative infinity. So that's the slight alteration from the three rules that I was telling you about. And in other words, it's not always exactly the same going to negative infinity as it is positive infinity. It has been on everything so far, because if the bottom is blowing up, then it doesn't matter whether we're going to negative infinity or positive infinity, the whole thing's going to zero. And plus zero is the same as minus zero. You see what I'm saying?
Yes.
Okay.
I think I understand it.
Okay. 17. What's 17 go to as we go to positive infinity?
Okay, so there are two x cubes, so it'd be 7.
Correct. How about negative infinity?
It'd be 7 as well.
Correct. In other words, I still end up with 7 times negative infinity cubed over negative infinity cubed. And both of these stay negative infinity, but then the negative signs cancel, so it leaves positive 7.
Okay.
About 18.
18 would be 9 over 2.
Correct. 19.
19 would be 0 because there's a bigger exponent on the bottom.
20. 20a.
Okay, so that would be x. Or no, x cubed over.
Yep. No, you're doing it right. Ignore everything else and just put x cubed over x squared.
Okay.
What's that go to as x goes to infinity?
Infinity.
What's it go to as x goes to negative infinity?
Negative infinity.
Okay, good. That's that little exception that you have to pay attention to. In fact, that's the only one we've done so far where there's different answers for A than B.
Yeah, that's true.
21. What's it go to as we go to infinity?
That would be, so 7, so 3 over 6. That'd be 1/2.
No, hold on. They're not the same exponent.
Yeah, you're right.
The first thing you want to think about is the numerator or the denominator blowing up faster than the other one?
It would be x to the 4.
They're the same exponent. They don't really, they blow up equally, kind of. And that's why it's the ratio of the coefficients. But when they're not the same exponent, it's never the ratio of the coefficients. It's either positive infinity, negative infinity, or 0 if the exponents are different. So what is it as we go to positive infinity?
Positive infinity.
How about negative infinity?
And it'll be positive infinity as well.
Right, because it's an even exponent. In other words, x to the 7th over x to the 3rd is x to the 4th. And if you took the limit of x to the 4th, as you go to negative infinity, it turns positive. Negative infinity times itself 4 times becomes positive infinity. And number 22. 22a.
Okay, so that would be x cubed.
Okay.
So for infinity, it'll be infinity.
Okay.
And for negative infinity, it'll be negative infinity.
Yeah, you got it.
So that looks like it's pretty much it.
I'm disappointed that they don't have an odd one that is comes to x to an odd exponent, because I would like to make sure their answer is what I think it is there. I'm a little concerned on 22 about that -4. Look at that. I'm not positive that's the right answer on 22. 22 is basically this. Which is -5/4 x cubed. And now, as x goes to infinity, that thing looks like it might go to -infinity. You know, I don't know. Here, let me find out. Before you go, I can find out real quickly.
Okay.
Going to Wolfram Alpha. Hold on a second. Let me, some of this stuff that's still processing. Wow. Well, when I'm doing anything else at the same time, it takes forever. When we started our session, there were 9 minutes to go to process this file. Now there's still 2 minutes because we've been doing other things at the same time. Let me just check the answer to one thing here. That's why I wish that they would have put an odd one in there. That is this problem. I think I can do limits, limit of, and I want to put negative x cubed. In other words, -1 times x cubed, and it should give us limits as it goes to infinity or -infinity. Yeah, it does. Notice that when it goes to positive infinity, it does go to -infinity. And when it goes to -infinity, it goes to infinity.
That's weird.
Well, it's not that weird. I get it. Because that minus sign, that has to play. I don't think you can ignore that, even though, and I think that's what we have in this problem, is that same problem. In other words, we've got 5x to the 8th divided by -4x to the 5th. So we do have a negative coefficient, and it's x to the 3rd. So when that thing goes to positive infinity, the whole thing goes to -infinity, and vice versa.
Okay.
That's interesting. I didn't know that. In other words, you can't quite ignore everything. I can ignore the 3, I can ignore the x, I can ignore the -2x cubed and the +9. But I don't believe I can ignore that -4. Yeah, no, you have to, especially when you're dealing with going to both infinity. Well, even if I was just going to infinity, I would have to pay attention to that -4. Yeah, and that's the first one they give us like that. In other words, 20 didn't have that. All right. Taylor, I'll talk to you next time.
Okay, thank you. Have a good night.
You too. Bye-bye.
Okay, bye.